Here I'm going to review inequalities. An inequality is an expression where we have something that's not directly equal to something else. Remember, if something is directly equal to something else, we have an equation, but if it's not directly equal to, either it could be less than or equal to, or it could be greater than or greater than or equal to, that's where we have an inequality. Now, how do we solve inequalities? We're going to go through a past paper question on the Leaving Cert. This is from about 2012, but first we're going to recap some of the rules of what we can do. So, adding or subtracting any positive constants or negative constants is absolutely fine. We don't have to change anything there. We don't change the sign of the inequality. When we're multiplying or dividing by a positive number, we also don't have to do anything. That's fine. The only difference here between this and an equation really is when we're actually multiplying or dividing by a negative number. If we know it's a negative number, then we have to change the sign of the inequality, or else it's not mathematically true. The tricky thing about inequalities, especially when we've got unknowns as denominators, we don't know whether that unknown is a positive number or a negative number. So that's where a trick comes in, and which I've written over to the right hand side there. If we have an unknown as a denominator, because we don't know whether it's positive or negative, i.e. we don't know whether we have to change the sign of this inequality here, then we have to multiply by the square of the denominator containing x. The reason is, when you square any number, we know it's positive. If we're multiplying by a positive number, and we know it's positive because it's a square, then we don't have to change the sign of the inequality. So that's the trick to this question. So, if we multiply, like I've said here, by 2 times x minus 3 to be squared, we're essentially eliminating all fractions. If you're ever trying to solve equations or inequalities, get rid of the fractions. It's the easiest thing to do first. That's what I'd always advise. So we're going to multiply twice x minus 3 squared. Well, that gives me 2x minus 5, which is here, times 2x minus 3. Remember, we had an x minus 3 as a denominator, so that's going to cancel, because x minus 3 will just cancel with x minus 3, because it divides into each other to give 1. Remember, if we're expanding out brackets here, it's going to be the first by the first, plus first by the second, plus second by the first, and second by the second added together to give this species here. And on the right hand side, that's what we have. We bring it all over to one side and we're left with, so bringing this over here, subtracting like terms, we're left with x squared minus 8x plus 15. Okay, what we can do is we can factorize that to give x minus 3 times x minus 5 is greater than 0. So now we have to think about what this question was actually asking for. Right? As an inequality like that, we're looking for values of x that satisfy this above equation. Well, now that we've performed mathematical operations and we're left with x minus 3 times x minus 5 is greater than 0, what we're essentially looking to solve here, we're looking for the x values where the curve is greater than 0. So what I would do to solve this is I would draw a quick sketch of the curve. We've got 3 and 5 there, it doesn't really matter, but we know that the curve goes like this. So this is the curve of this quadratic here, a rough estimate of it. Now, we're looking for the values of the curve which are greater than 0. So the lines that I've put in black here are where my curve, I just highlighted here, is greater than 0. So my curve is greater than 0 for all values of x going that way and all values of x going that way. Okay. If I'd ended up with an equation where these things were less than 0, so that inequality was swapped around, then the values of x I'd be looking for would be here, because this is where my curve is less than 0, so my x value would be between 5 and 3. Okay, but in this actual question, we're looking for the values of x where the curve is greater than 0, so the curve is greater than 0 where x is less than 3 that way and x is greater than 5 that way. So that is my solution set. The values 3 and 5 there are called our critical values. Another way to make sure we've got the right solution set is if we pick a number between our critical values, let's say 4, and we plug 4 into this inequality there, we get 16, because that's 4 squared, minus 32 plus 15, which is equal to minus 1. as minus 1 is not greater than 0, this inequality is false. So the solution set doesn't lie between the critical values. Okay, if we'd got a value like 1 for this, then that is true because 1 is greater than 0, and therefore the solution would lie between the critical values, i.e. x is between 3 and 5. But here, because we plugged in a value between our critical values and we got an answer of minus 1 when we plugged it into this equation, the inequality there is false, so the solution set doesn't lie between those critical values.